statement, it has two parts. First part is known to be subject and the second part is known to be predicate. So like this, let us consider. So today we'll just discussing predicate calculus. What is predicate calculus? The part of logic that deals with predicate, quantifiers, okay, is known to be your predicate calculus. So next is, let us consider an example. I am writing here x is greater than 5. So x is greater than 5. So whether this one is it a proposition? Not at all. Not at all. This is not a proposition at all. Because the value, as per the previous discussion, as the value of x is not given, we cannot say this one is a proposition, but this one can be said to be a propositional function. How? You see the first part. What is the first part? First part is x, which is known to be the subject. Second part, what is the second part? Is greater than 5. That is the predicate. Okay. So if I am writing is greater than x as p, means for predicate, and x is your subject. So combining these two, I can write p of x. What this p refers? The predicate. What this x refers? The subject. So whatever the property satisfied by the subject is greater than 5. And whenever the value of x is given, then we can be able to say this is a proposition whose value may be true or may be false, but cannot be both. So this is one way to define a proposition. So that I can able to say this predicate calculus is a way to define propositions. Am I clear? What I have said? Let us consider I am writing here C, another example. C is going to the bus stop. So is it a C is going to the bus stop? Is it a proposition? Not at all. Because, so which one is your subject? C. What is the property satisfied by her? Is going to the bus stop. So that is going to the bus stop is your predicate. And which one is your subject? C. But whenever I will confirm the name, then it becomes the subject. So it becomes the name of C. In place of C, if I am writing any name, then it becomes a proposition. So just like expressing general function, just like writing a expression in short form. Okay. Here also, any mathematical expression, whatever given, if we are able to confine or if we are able to find the subject and the property satisfied by it, then the subject we are defining as x or as y or as z, anything else, and the property satisfied by it is your predicate, and combining them we are getting a function that is known to be propositional function. And whenever the value of the variable is assigned or is given, then it becomes a proposition. Okay. Let us consider I am writing another example. x equal to y plus 3. How many variables are involving here? Two variables, x and y. So what are the properties satisfied by them? Y is 3 less 2x, or x is or x equal to y plus 3 means x minus of y equal to 3. So what is the relation or what is the property satisfied by them? The difference between x and to that of y is 3. So if I'm writing here x and y are the subjects, then what is the property? Property is the difference between them is 3 in the subject, sorry, is the predicate or is the property satisfied by them? And then if I'm writing here q, so now qxy becomes a propositional function. And when the value of x and y are put or are x and y are given, then we can able to say this happens to be a proposition whose value may be true, may be false, but cannot be both. Let us consider another example. I am writing x plus y is equal to z. How many variables are involving here? 3. X plus y equal to z. Okay. How many variables are involving here? 3. So there are 3 subjects. Then what is the property satisfied by them? The property is the sum of first two variables is equal to the third variable. Sum of first two variables is equal to the third variable. That is the property. So that if I am taking R is the predicate or as R is the property satisfied by them. And what are the subjects? X, Y and Z. So whenever the value of X is given, the value of Y is given, the value of Z is given, then we can say this propositional function becomes a proposition. Unless and until the values of x and y and z are not given, we cannot say this is a proposition. Okay. So that by this predicate calculus, better I can say by using the propositional function, we can able to find or we can able to declare a statement to be a proposition whenever the value of the subject is given. Okay. Also, by using certain concept, we can able to translate a proposition to its compact form. But before that, I am going through quantification. Because using both this predicate means the propositional function as well as quantifiers, we'll just try to translate a given proposition to compact form. So before going to this quantification, I must say you, there are certain propositions or statements you are getting in English literature that there is one and only one person in India who can beat a particular challenge. That means there exists a single person in India who can face this challenge. That means this particular person is unique. Try to hear it particularly, the examples. Let us consider the second example, that all students of first semester MCA has to appear has to appear MCS-13 on a particular day. Appear the exam or test of MCS-13 or each and every or all the students. First one, I am saying that there exists a single person. Single person. Third example is just here. Rohit Sharma is the one and only one cricketer, international cricketer, who has scored double century 2 times in one-day cricket. Okay. Just consider my 3 examples. If I just try to convert this given statement, because all of them are declarations, if I just try to convert them to equivalent logic form. So, first one I have said, there exists a person. There is one person in India. Then, who can face this challenge? That means there are several persons in this universe or several persons in India, but he is one of them. Out of some people, you are selecting one and saying that he or she can face the challenge. Second example I have said, every student of first semester MCA has to give the exam of MCS-13 on this particular day. That means each and every student has to be examined, or each and every student has to specify the property. Okay. And third one, what was the third one? Third one I have said, Rohit Sharma is the one and only one cricketer international cricket who has scored 2 double centuries in one-day format. That means he is the only one, no one else in the total universe who has scored 2 double centuries in one-day format. So, in order to specify this, there exists, or for all students, or there exists one and only one cricketer. In logic, we need quantification. Okay? We need quantification. What are quantifications? Quantification is required only when the statement is followed by some auxiliary adverbs like there exists, there is one and only one person, or one and only one thing, or for each and every students, or for each and every kinds, or for each and every categories. Okay. So in logic there are 3 quantifiers. One is existential quantifier. The symbol I am just writing here, but I will show you. First one, that is existential quantifier. Second one is universal quantifier, that is inverted V, which is cut. Then this one is universal. And third one is unique. Unique quantifier. So generally there are 3 types of quantifiers available in logic. One is existential quantifier. Other one is universal quantifier. Third one is unique quantifier. So where you are getting the example, that is, there exists a person. There exists a person. That means there are certain persons and you are selecting one who can face this challenge. At that extent, we are writing or using the quantifier as there exists. As I have said, all students of first semester, all students, for all, at that extent, we are using universal quantifiers. Okay. In the third case, what I have said, there is only one and only one person, one cricketer, namely Rohit Sharma, who has scored 2 double centuries in one day format. One and only one. That means he is the unique cricketer. He is the unique cricketer. No one has done this one. Or I can say, Mahatma Gandhi is the one and only one person who has taken the concept of non-violence for freedom concept, freedom of India. Okay. So he is the only one person, no one else has taken that concept to make India to be free. So there, what is the syntax whenever you are using quantifiers? So the syntax is syntax for quantification is, first of all, the quantifier, followed by the variable, followed by variable or subject, followed by propositional function. So if I am asking to translate the first one, there exists or there is a person who can face this challenge. So person is your subject. So there is a person. So I can write there exists X. What is the property satisfied by him? He can face the challenge. So the property, let us consider I am writing P of X. So there exists X, P of X. Second one, if I am saying, I am just trying to translate. All students of first semester. Who are the subject? Students are the subjects. So all as for all. So we can take the help of universal quantifier. So I can write for all X has to be examined for MCS 013. So if I am writing M of X is the predicate or propositional function. So I can able to write for all X, M of X. In the third example, if I am writing the same concept, so I should write the unique quantifier X, then Rohit Sharma is the only one, so R of X. Okay. So by using this three quantifier, where this unique quantifier is a rare one, and all others existential as well as universal, they are very much used in logics or in predicate calculus. As for the example, if I am just saying that, let us consider I am simply translating one thing, that a lady, here the example particularly, a lady is a tailor, is a housewife and mother of a child. Let us discuss this one. lady, not particular word, you should say woman. A woman is a housewife, a seamstress, or you can say a lady tailor, and mother of a child. For the woman, if I am using the subject is your ex, okay, so that woman is a housewife. So if I am writing H of X is the woman is a housewife, then she is also a lady tailor. So if I am writing T of X, is that woman is a lady tailor? And third one, I have said the third property is what? The woman is the mother of a child. That means X is the mother of somebody, mother of a particular child. So child is another subject. Try to define Y be the child. So that what I can write here, mother of the child, mother of the child. Who is the mother? X is the mother of Y. X is the mother of Y. So if I am writing here My, so how I can able to translate this one? I cannot write for all. I should say there exists a woman. There is a woman. Means existential quantifier should be used. So there exists X. Then M of X. Sorry, housewife you have written. So H of X. Conjunction. Because why conjunction you are writing? And he is a lady tailor. Conjunction T of X implies M of Y. Why implies M of Y? Why implies M of Y? Because X is the mother of Y. But there is certain concept is there. So what is the concept? How many variables are there? X and Y are two variables. You cannot, how many variables are used in a particular quantified statement? Each and every variable is associated by some quantifiers. So that two quantifiers are there, must be there. Because this woman cannot be the mother of all child. So it is the mother of a specified or particular child. So that we must try to initialize that child to be also a particular child, means a single child or a a particular child. So we can just use, again there exists, for this quantification should be there exists also or existential quantifier for Y. So the statement should be there exists X, there exists Y, M of X, sorry, H of X, conjunction T of X implies M of Y. Okay. So that by this way we can able to write or convert the given statement to equivalent logic form. Okay. Then what is the algebra of quantification? So negation of existential quantifier is unique. Negation of existential quantifier is universal quantifier, and negation of universal quantifier is existential quantifier. Then negation of unique quantifier is universal quantifier. So when we are considering negation of existential quantifier, it gives universal quantifier, and whenever you are taking negation of universal quantifiers, we are getting existential quantifier, and whenever we are getting negation of unique quantifier, then we are getting universal quantifier. Okay, this is all about. So by this way also, by this quantification also, we can able to define a proposition, so that in including propositional function as well as this quantification, we can able to derive or define the propositions, and correspondingly the truth values we can able to get through it. Okay. So next proceed to proofs. Certainly the mathematical proofs are based upon some concepts, and those concepts are known to be the laws of inference. So what is the laws of conference as laws of inference? So if you are just saying, let us consider one example in this regard. So first I am saying, it is raining. We will not go to the restaurant. So I am saying it is raining. Let us consider P is it is raining. What is your cue? We we will not go to the restaurant. Okay. If I am taking the first part, that is it is raining as your P, and will not go to the restaurant as your Q. So in proof strategy, we are using the implication. So generally we are writing P implies Q. So the first part, that is P, is known to be your hypothesis or antecedent. The second part of this implication, that is Q, is known to be consequent or the result. Okay. So here we have taken P is your, it is raining as your P implies Q. So we can able to say if it is raining, then we will not go to the restaurant. Okay. If negation of if P is there, so if P is true, that means if it is raining is true, then what will be? The Q will be automatically true or not? Q will be automatically true. So we are saying henceforth Q. That means Q will be automatically true. This rule particularly is known to be your modus ponens. Modus ponens. That is also known to be law of so that is known to be your modus ponens. What? As I already have said, in proof concept, it is always given in this form of P implies Q, where P is known to be your hypothesis or antecedent, and Q is known to be your consequent or result. So if P is true, henceforth Q must be true. Otherwise, the resultant value cannot be true. Why the resultant value cannot be true? Because your proof strategy always needs that the statement to be proved to be true, not to be false. Okay. So this concept is known to be your modus ponens. Like thus, if I am saying another form, that is modus tollens. So if I am saying here P implies Q and negation of Q is there, then automatically by the concept of contraposition, you can say the result to be negation of P, because already you have got P implies Q has three forms. One is converse, another one is inverse, another one is contraposition. So negation of Q must implies negation of P to be true. Henceforth, the resultant value to be negation of P. This concept is known to be your modus tollens. Mind it, all these things always comes as short questions. Then another one is known to be your hypothetical syllogism. What is hypothetical syllogism? Let us consider P is a statement that it is cold. Q is a statement that we will not take ice cream. Okay. Third one is R is a statement. Let us consider that says we will take tea. So if I am writing P implies Q, Q implies R. That means if it is cold, then we will not take ice cream. Then Q implies R. What it says? If we are not taking ice cream, then we will take tea. So using these three statements, what you are saying? If it is cold, then we will take tea. This set of things are known to be hypothetical syllogism. Another example, numerical example I am saying. 9 is greater than 7. 7 is greater than 4. So what is the conclusion you are getting? 9 is greater than 4. This is because of hypothetical syllogism. Okay. So that the laws of inference actually we are dividing, or we are just getting three types of concept. One is modus ponens. Second one is modus tollens. This one, sorry, previous one. And another one is hypothetical syllogism. And another small concept is there. That is law disjunctive syllogism. So what is law of disjunctive syllogism? Let us consider P. P is today is cold. Q is, let us consider another proposition, that is Q is this month is March. So if I am just writing P disjunction Q, will it be true or not? Because either of them must be true. If either of them will be true, then the resultant truth value is true. Or if one of them, if both of them are true, then this is also true. If both of them will be false, then the resultant truth value is false. So that it will give you a disprove. Okay. That's why 4 laws of inference you should keep it in your mind. One is modus tollens, that is known to be a rule of direct inference. Second one is modus tollens. Third one is law of hypothetical syllogism. Fourth one is law of disjunctive syllogism. Basing upon this concept, we are getting proofs. Generally, all the proof strategy are governed by this principle. So basically, what is proof then? Is there any difference between proof PROOF and PROVE? Is there any difference or not? Yes. What is proof then? I am giving you a small example in this regard. So all of you have proved the concept, that is, in geometry you have done this one. Sum of two sides of a triangle is greater than the third side. So in order to prove this one, what you are doing? You are taking several strategy. What is your first strategy? You are constructing different type of triangles. A right angle triangle, a acute angle triangle, a obtuse angle triangle, so on and so forth. Then the second case, whatever happening, you are measuring all these three lengths, okay, and then you are putting all those values in a table. Figure 1 is a right angle triangle whose AB is this one, BC is this one, AC is this one. Then next figure, also we are writing ABC is an acute angle triangle where AB is this much, BC is this much, and AC is this much, so on and so forth. And in the next part, what you are doing, you are adding on each and every cases you are adding AB plus AB plus BC. In all the cases you are adding and you are getting that it is greater than AC. Then in the conclusion part, you are writing the sum of two sides of a triangle. Sum of two sides of a triangle is greater than the third one. Third side. So that whatever the steps you have taken in order to prove the statement to be true. What are the steps? First, you are drawing the triangles, different type of triangles. Second step, you are measuring all these sides. Third stage, you are getting going for the tabulation. Fourth stage, you are getting the conclusion one by one. And the last step is you are giving the exact conclusion or exact observation considered or taken by you. All these steps are known to be proof. PROOF. So what is proof? Proof is a sequence of valid mathematical expression written in a proper order in order to prove a statement. In order to prove PROV. In order to prove a statement to be true. Am I clear? Proof is a sequence of valid mathematical statements written in a proper order, proper sequence in order to show a statement to be true. Okay. Then what is proof then? The concluding part of the proposition is known to be your proof. Concluding part. Whatever the conclusion finally you are getting, the sum of two sides is greater, sum of two sides of a triangle is greater than the third side. That is the concluding part. That is your PROVE. To this context, you are getting also different terms like lemma, corollary, conjectures, etc. What are lemma? So lemmas are the search theorems using which we can able to prove a theorem to be true. Lemma means small theorems or small statements that are proved to be true, and using which we can able to prove a statement or a concept, or we can able to prove a theorem. And what is corollary? Corollary is the derived fact. Using a theorem or directly employing or using a theorem, whatever the results you are getting, so that is corollary. What is conjecture? Conjecture is a theorem or conjecture is a statement, and whenever it is proved, then it can be a theorem. So that is the part of what I can say, part of the literary concept. Okay. So here the inference or the rules of inference, whatever used by this concept, we can also define methods of proof. So generally there are various methods of proofs are there. What are they? The first one is direct proof. Second one is indirect proof. Then third one is trivial proof. Fourth one is vacuous proof. Then there are also different type of proofs like proof by cases, proof by equivalence, so on and so forth. That is not included in your course. And the fifth one is the most important concept, that is proof by induction. So generally, here we will just discuss these 5 types of proof. One is direct proof. Another one is indirect proof. This indirect proof is also divided in 2 categories. One is proof by contradiction. Another one is proof by contraposition. Likewise, the proof of induction is also divided into 2 categories. One is weak induction, or that is otherwise known to be first principle of induction. Other one is known to be strong induction or second principle of induction. Okay. So let us think of the first one, that is direct proof. As I already have said, any set of proof concept can be logically expressed as either P implies Q or Px implies Q of X, where this P is known to be, the first part P is known to be your hypothesis and Q is known to be your conclusion. So in case of direct proof, the hypothesis is accepted to be true. Whatever the proposition P is given, that you are accepting to be true. As you are accepting that one to be true, then we are supplementing some valid mathematical arguments. Okay? In order to reach at Q, in order to reach at the conclusion, so that this concept or this strategy is known to be your direct proof. So in case of direct proof, whatever the hypothesis or antecedent is given, that is assumed or accepted to be true, and then we are giving, or we are just supplementing some basic valid mathematical concepts, arguments, so that we can read are the consequence or the result. This is the strategy of direct proof. As per this one, let us consider the example. I am giving you the example. The sum of two positive positive odd integers is always even. So what will be your P or what will be your hypothesis? Sum of two positive odd integer. Sum of two positive odd integers. What will give the result? The resultant is, it will give you an even integer. Okay. So as you know, whenever you are just writing any proof and you are using any strategy, first of all give the declaration. So how you are declaring? Write directly by direct proof. So in this particular concept, whatever given, the sum of two positive odd numbers. How we can able to define a positive odd number or odd integer? Any positive odd integer is always expressed in forms of 2m plus 1, where m is an integer. And 2m plus 1, if I am writing 0, so we are getting 1, that is odd. If I am putting m equal to 1, you are getting 3, is it odd or even? If I am putting 2, then I am getting 5. Then if I am putting 3, I am getting 7, so on and so forth. Are you getting odd integers or not? So any odd integer in mathematics can be represented in the form 2m plus 1 or 2n plus 1. Okay. Then, so I am writing, let us consider x is a number that is in the form of 2m plus 1 as it is an odd integer. Let us consider y be another integer which is also an odd integer. So let us consider the general expression is 2n plus 1. Okay. So if I am just adding x plus of y, so whatever the value you are getting, 2 into m plus of n plus 2. So if I am again I am taking common, I am getting 2 into m plus of n plus 1. So that 2 multiplied by, as m is an integer, n is another integer, whenever the sum of two integers is another integer, plus 1 is another integer, and whenever it is multiplied by 2, are you getting an even number or not? Yes. So that it is an even number. So that we have taken the concept of direct proof. What is in direct proof, what you are doing? We are accepting the hypothesis, that is what is given, that is to be true, and then using the mathematical concept. Whatever the mathematical concept, I have defined x as an odd integer, so that is 2m plus 1. Then I have defined y is another odd integer, I have defined that one as 2n plus 1, and then adding them, we are sufficing or we are supplementing some other concept, that is this becomes 2 into m plus n plus 1, that is 2 into some positive integer is another or is an even integer. Hence the proof. Okay. This is all about your direct proof. Let us consider indirect proof. In case of indirect proof, that is either proof by contradiction or proof by contraposition. In case of contradiction, we are considering the concept of inverse. As already I have said, there are three forms of P implies Q. One is converse, another one is inverse, another one is contraposition. So in case of contradiction, we are considering the case of inverse. And in case of contraposition, we are using the concept of the form, that is contraposition. As you are very much familiar with the concept, that is square root of 3 is an irrational number. So all of you have learned this one to a greater extent in your earlier stages. Yes or no? How you are doing? You are accepting the contrary. What you are writing? Let us consider square root of 3 is an rational number. So is it negation of p or not? Then you are using the property as you are accepting that this one is a rational number. Then you are saying that any rational number can be expressed in terms of a by b, where a and b are any two integers and they are in list form. That means there is no common factor in between a to b and b is not equal to 0. As a by b and b is not equal to 0, then it must be a fraction. And as they are in simplest form, so that a cannot divide b or b cannot divide a. Then as you are writing here, square root of 3 is equal to a by b. If I am squaring both the sides, you are getting here 3 equal to a square by b square, or you can say a square equal to 3b square. As a and b are in list form because they don't have any common factors. So b square cannot divide a square. As b doesn't divide a, so b square cannot divide a square. That implies what? 3 must divide a square. Or we can write 3 must divide a. My logic is clear or not? We have taken square of this expression. You have got 3 equal to a square by b square. So that from this side you are getting a square is equal to 3b square. As a and b are in simplest form, that means that the GCD, greatest common divisor of a and b, is 1. That means a cannot divide b or b cannot divide a. So whatever the expression you have got, a square equal to 3b square. So as b cannot divide a, that implies b square cannot divide a square. So which one then divides a square? 3 must divides a square. As 3 divides a square, 3 must divide a. Okay? Because 2 divides 4. 2 also divides itself or not? 3 divides 9. 3 divides 36. 3 divides 6 or not? So 3 divides a. That implies a is divisible by 3. Can I write a equal to 3k or not? As a is divisible by 3, can I write a equal to 3k or not? So if I am putting here in the said expression, so I am getting here a square equal to 3b square. That means I can write here 9k square is equal to 3b square, or b square equal to 3k square. By employing the same logic, we can able to say 3 divides b square. That implies 3 must divide b. So 3 is 3 is a common factor of a as well as b, which contradicts the given concept, or that contradicts or the assumption that we have already assumed, that a and b has the GCD, or greatest common divisor, is 1. Now you have got 3. Is it a contradiction or not? So as it is a contradiction, hence the assumption that you have taken square root of 3 is a rational number is false. Hence the proof. That is known to be a proof by contradiction. Okay. What you are taking? Whatever the hypothesis you are given, try to take the negation of the hypothesis. Taking negation of the hypothesis and giving relevant mathematical proof strategy or relevant mathematical statement. If we cannot get the resultant value, then we are just arriving at a contradiction. That's why the proof is known to be method of contradiction or proof by contradiction. Okay. So next come to contraposition. In case of contraposition, what the strategy is? You have to assume negation of Q and you have to. So what is the form of contraposition? Negation of Q implies negation of P to be true. So let us consider one example in this regard. So the example is given. So what is the, let us consider the example that is, if x, y belongs to set of positive integers. That means x, y belongs to capital Z. Then both such that x multiplied by y is odd. Then both x and y will be odd. My question is clear or not? Give the proof by contraposition that if x, y are set of or x, y belongs to the set of positive integers such that x multiplied by y is an odd integer, then x and y must be odd integers. So what is the condition given? First condition is x and y are positive x and y belongs to this set of positive integers. So what to be proved? If x multiplied by y is an odd positive integer, then x and y should be and must be positive odd integers. So what is P here? What is your hypothesis here? X into y is a positive odd integers. Odd integer. What is your Q? X and y must be odd positive integers. Such the proof is by contraposition. Try to take negation of Q. What will be negation of Q? X is an positive integer, y to be an positive y to be an x to be an even integer, even positive integer, y to be another even positive integer. So what will be their product? When x will be positive even number, can I express them that as your 2m or not? Where m is an positive integer. And whenever I am saying y is another positive integer, even integer. So can I write y to be 2n or not? So that multiplying x and y, how much you are getting? 4 into m into n. So can I write that one is 2 into 2mn? So whatever you have got, whether this one is an odd integer or even integer, even integer. So multiplication of two even numbers is an even number. Henceforth, the contrary. That means henceforth the product of two positive odd integer is an odd integer. Okay. So next, trivial proof and vacuous proof I will just give you because these are small proofs. I'm saying just moving through induction. The most important concept is induction. So whenever there are certain proof you will get which are not or which cannot be proved by applying direct proof concept, which cannot proved also by applying indirect concept, which cannot be proved by any other proof strategy. At that extent, we are considering the methods of induction or proof by induction. Okay. In this proof of induction, this induction has a structure. Maybe first part, maybe second, maybe weak induction. As already I have said, it is divided in two categories. One is weak induction, another one is strong induction. Okay. Sometimes you are getting a short question. What is the structure of induction? So structure is first of all declaration. So declaration means you have to write in each and every proof. Whenever you are proving a statement or you are proving a concept, which strategy you are applying, try to write the heading or give the declaration first. That is the basic strategy. So first of all, in case of induction, first one is declaration. Declaration means you must write proof by induction. If you are writing weak induction, that is okay. If you are making second strong induction, you should give the declaration proof by second principle of induction or strong induction. Okay. Then whatever the concept is given, try to formulate it mathematically. Okay. After formulating them mathematically, try to check the formulation is valid for the initial values of the domain of discourse or not. So my first one is try to check whether the mathematical formulation is valid for the initial values of the domain of discourse or not, or for the initial values or not. And that is known to be your basis. So first one is declaration of the proof, second one is basis. So in basis what you are doing? You are checking the expression is valid for the initial values of this given discourse or not. Followed by, after this one, if it is valid, then you are assuming that let us consider the statement is true for an interim value, that is k. And then we want to prove for k plus of 1. Okay. Let us consider I am writing the statement is given in the form of Pn. So if in basis step you are using P1 is true, then in the induction step, next step is induction step, then you are assuming that Pk is true. What is K? K is an interim value which is greater than 1 but less than n. Strictly less than n. Then you are assuming that the statement Pk is true. And then using the very concepts, you are just trying to prove that the statement is true for k plus of 1. As it is true for 1, as it is assumed to be true for k, and now we are proving that the statement is true for k plus of 1. Hence, the proposition or the given statement is true by induction. Okay. So here, in general, there are three steps are there when we are proving by first principle of induction or weak induction. What is that one? First one is declaration. Second one is basis step. In some books it is written basic step, but that is known to be your basis, where the initial values of the domain of discourse is discussed or is checked whether it is true or not. If it is true, then you are going to the induction step. In induction step, you are assuming k be an interim value that lies in between 1 to n, and you are assuming that the statement is true for k, and then you are trying to prove for the value that is k plus of 1. If it is true, then the proof is true. This is the structure for weak induction. And then here also I want to say, when you are writing that this statement is true for an interim value of k, that particular step is known to be your induction hypothesis. The particular step where you are assuming that the statement is true for k, where k is an value, it is lies in between 1 to n. That particular assumption is known to be your induction hypothesis. Okay. Then I will give you one more proof. Sorry, I will give you a proof and how to write that structurally, that I will show you. Then second one is strong induction. In strong induction also, the structure is very much similar. But what is the difference? First part, the declaration should be given that this is proof is by induction. Better you can write strong induction or second principle of induction. But in the basis step, what you are doing? More than one values are checked. Here simply we are considering only one initial value. But in case of strong induction, more than one initial value are checked. P1 is true, P2 is true, P3 is true. More than one initial value is checked for the given statement. And the induction step, it is very much similar. Then you are assuming in basis step only there is some changes in the second principle of induction, but in induction step there is no change at all. Okay. How to write all the proofs, that will give you tomorrow. So right now I just want to know the previous day whatever I have sent, have you gone through it? Yes. Anybody else? Previous day. Okay. So this is all about today. I'll send that one and Vijay will send to you all. Okay. This is all.